So your homework from your book, page 913. Number 19. Try direct substitution first. Well, if I plug 2 in, 2 minus 2 gives me 0 in the denominator. So I have to do another toolkit strategy. I'm going to factor. Cross them out, then apply direct substitution. 2 plus 3 is 5. So number 21 here, guys. I plug in -2, I get 0. I say, okay, I'm going to factor. Well, Mr. Esther factored, and then I looked later and said, okay, -3 times 2 don't give me a positive 6, does it? So can that be factored in the numerator? No, that can't be factored. So when something can't be factored like that, then what I would literally do is put it in my calculator and look at the behavior of the graph. So let's do that in your calculator right now. Remember, you can always graph it to actually see what's going on. That's a real strange graph, guys. I wouldn't give you anything like that. -2 is right here, isn't it? Well, we only approach it from one side, don't we? We don't have anything from the other side. We have to have two sides to say it's a limit, don't it? That's why it does not exist. That is crazy. I won't give you something like that. You got -2 here. You only got it's on this side, so wouldn't have anything like that. So that does not exist. All right. Look at 23. The limit as t approaches -3. I plug -3 in this denominator, I get 0. So I start factoring. In the numerator, it's the difference of squares. In the bottom, let's bust them up. I cancel out the t plus 3, and then I apply direct substitution. When I plug -3 in now, I get a -5, and I get a -6. -6 divided by -5 is 6/5. So that is A-okay. All right, number 25. As h approaches 0. Now, this is what your quiz is on tomorrow. Quiz on everything we learned this week. As h approaches 0, I plug 0 in. I have 0 in the denominator, so that can't work. So I start playing around with it. I got 2 plus h squared. I'm going to FOIL that out and see what I can do. I FOIL that out. 4 plus 4h plus h squared. Cancel the 4 and the -4. I'm left with 4h plus h squared over h. Well, I factor out an h because I'm trying to cancel out that h on bottom. I did that and left 4 plus h. So I did direct substitution. 4 plus 0 is 4. Are there any questions so far? All right, 27. I'm going to rationalize the numerator. And don't let this math beat you, okay? You're going to rationalize and change that minus to plus. FOIL it out. Take your time. When I got down to here, I applied direct substitution. Plug 7 in. Still gave me 0 in the denominator. So I'm going to use factoring. So I started grouping things together. I grouped my radicals together because I can pull out that radical. GCF. Pull it out. Then I can pull out a 3. X minus 7 cancel out. What's left on the numerator? 1. 1 over this. And I get the value of 1/6. The limit as x approaches 7 of this function is it's approaching the value of 1/6. Are there any questions on number 27? Okay. Number 29 is -1/16. I'm going to find a common denominator of 4x. That's going to be x plus 4 over 4x divided by 4 plus x. Come under it. I'm going to write what that means. Cross those out. X plus 4 and 4 plus x is the same thing. They all have the same sign, so I'm going to cancel that out. 1 over 4x, apply -4, and I get -1 over 16. Are there any questions on your homework? You good? You understand what's on your quiz tomorrow? Okay, let's look up here for a minute. Let's review. I want to make sure all this flows together, what we've done so far. First part of the week, we learned how to find a limit using a table and a graph. Table and a graph. Now graph, we have done overall limit, like x approaches 3. That means you have to look at both sides, don't it? But we also look at one-sided limits. I call these, the mathematical term for these are one-sided limits. I call this an overall limit. They just normally call it a limit, but so we just distinguish between these two types. This is overall limit, this is one-sided. Is everybody good? The third target for this week was I can find a limit of function algebraically. Now, when we did algebraically, what you did for homework, what type of limits were we working with? Overall, the entire limit. Well, today we're going to learn how to find one-sided algebraically. Okay, do you understand the difference? We're going to look at, they're easy to look at the graph. That's why I went ahead and did that up front. Now, it's a little bit more complicated when you're doing algebraically one-sided, okay? So that's what we're going to work on today and tomorrow, okay? Does everybody understand where we're going with this? So that's our target, how to find one-sided limits algebraically. All right, so I want you to turn to page 5 in your notebook, please. We started this yesterday. And I told you I apologize for the poor copy. So if you want to look up here, once again, I'm truly sorry for the copy looking bad. I went and drew the tick marks darker up here. This won't give you any trouble because we already practiced this week. So let's look at this. The first one, I want the limit as x approaches -6 from what direction? Left. So I go to -6. It's right here. From the left, it's approaching what y value? -1. From the right, it's approaching what value, Conley? What value is this up there? 4. Very good. All right. Now, we want to just know what is the f of -6 value. Would I choose the -1 or the 4, guys? -1. Very good. Number 4. The limit as x goes to -1 from what direction? Left. Okay, I go to -1. -1. Brendan, what is it approaching from the left if the x value is at -1? What is it approaching? 2. Very good. From the right, it's approaching what, Taylor? 2. Very good. What is my f of -1 value, Sean? 3. Very good. It would not be 2 because it's open dot. There's a closed dot right above it, so it's 3. It's approaching 2, but the actual value is 3. Number 7. The limit as x approaches 3 from the left. I go to 3 right here. We talked about this yesterday. What's happening at 3 right here? There's an asymptote. It's shooting straight down or shooting straight up. So Zach, if I'm approaching it from the left, where's it going? -infinity. Very good. Okay. Reese, from the right, it's going where? Positive infinity. Very good. Now, if I had asked you for the overall limit here, you got one going to infinity, one going to positive infinity. What's the overall limit? Does not exist. Very good, guys. All right, f of 3. Do I have a point or anything for f of 3? So what is this going to be? Does not what? Exist or undefined, whatever you want to put there. Number 10. The limit as x approaches 8 from the left. 1, 2, 3, 4, 5, 6, 7, 8. Ooh, what's going on right here? There's a what right here? Okay, what's going from the left? It's going to be what? -infinity. From the right is what? -infinity. If I would have asked you for the overall, did those two match up? Yeah, so what will be your overall if I asked you for the overall? -infinity. Do you understand that? Because they're both approaching the same value. Does that make sense? Okay, look here. From the left, this thing is going straight down, isn't it? From the right, it's going straight down. There's an asymptote right there. Yeah. What is f of 8, guys? Does not exist. Now we're looking at 5 from the left. 1, 2, 3, 4, 5. I'm right here. Right here. From the left, it's approaching what? 0. From the right, it's approaching. So what's f of 5 equal right here? 0, because it's on 0. There's no open dot. That's very similar to what we did at the beginning of the week, isn't it? Now let's look at the mathematics part. Algebraically, we're going to look at piecewise for a minute. Alright. Now let's look at this piecewise here. This is the, okay. The important number is 1 here, isn't it? That's where you get on and off the train at. What part is to the right of 1? The top or bottom? Top, because isn't that the greater than? The less than would be the left part of it, wouldn't it? So I want to know, what is the limit as x approaches 1 from the left? Where would you plug that in? Top or bottom? Bottom, because that's the left part, isn't it? So 2 times 1 is? Plus 3 is? Does that make sense to you? Okay, this is as x approaches 1 from the right side. So I would plug that into the which one? Top. Very good. 1 squared is 1 plus 1 is 2. So I did the left part, the right part. Now I want the overall limit. Well, I just did the work. Are these the same? So what is your overall limit? I'm going to throw this in here. What if I asked you for f of 1? I'm not asking you for the limit. These are the limits. I'm asking you for the actual value. Where would you plug that into? Top. 1 squared is 1 plus 1 is 2. Now, you want the limit as x approaches 5. That has nothing to do with this turning around point. The discontinuity is there, isn't it? So you just do that 5 just like if you were doing f of 5. Where would I plug that 5 in at? 5 squared is? Plus 1 is? 26. Because that's just a regular part of the graph. This is where the discontinuity is taking place. That's where you got to check both sides. Alright, let's look at number 17. Let's look at what we got going on here. We got this part of the function for every number that's not equal to negative 3. The only time you use this is if x equals negative 3. Okay? Oh, by the way, this is supposed to be little x approaches negative 3 down here. Not, oh, I'm sorry, not on that last one. Just these first three are supposed to be negative 3, negative 3, negative 3. Okay, so you have to think about this. If I'm at negative 3 and I'm coming from the left of it, what is left of negative 3? Negative 4, isn't it? Which one of these I plug in for negative 4? I'll use this for everyone not equal to negative 3, so I would plug negative 4 in for this one. Does that make sense? Okay? So, negative 4 squared is what? 16 minus 9 is? Now, let's do this. Hold on.
Where did you get negative 4?
What now? No, I said change these to negative. Yeah, the first 3, because I meant that to be negative. Hold on just a second, Conley. I know what you asked me. Hold on. No, you're supposed to plug in negative 3. I'm sorry. That's right. All right. You're right, Conley. All right. We're going to plug negative 3 into this right here from the left. Negative 3 squared. Now you said, Mr. Chester, could I factor this and break it down? Yes, you could. You see I cancel those x plus 3's out? Because you always try direct substitution first. I plug negative 3 in. I got negative 3 plus 3. I got 0 in the denominator. Well, you know, if you get 0 in the denominator, you need to break it down. So I broke this down right here before I plug negative 3 in there. Now, negative 3 minus 3 is negative 6. Well, from the right, that's not going to affect it, so it's still going to be negative 6. So I plug negative 3 in. Since these are both the same, what's your overall limit? Very good. Now, I'm going to plug in, okay. I plug in 4, direct substitution. 4 squared is? 16 minus 9 is? 7 over 7 is equal to what? 1. I don't really like that problem, so you're not going to have one like that, but we got through it. Let's look at number 18. These are the type you're going to have. 16, 18, and 19 is the type you're going to have. Because these are true piecewise. 16, 18, 19. 17 is not a piecewise. That's just a weird one. So 16, 18, 19, piecewise. Okay, so let's look at this. We have two pieces. X is less than 1. So where's that going to be, on the left side or the right side? X is greater than or equal to 1. That's on the what side? Right side, okay. I will know what the value of X as it approaches 1 from the left. From the left. Where would I plug that in? On the top. You got me? What's negative? I'm going to reduce direct substitution. Negative 1 plus 1 is 0. 0 plus 1 is, oh, well, never mind, you're right. I'll do it again. That's 0. Okay, from the right, I'm going to plug it in here. 1 minus 2 is? Negative 1 squared is? Negative 1 plus 1 is? 0. Okay, from the left is 0, from the right is 0. What's my overall limit? Because these are the same. Very good. Now, I'm going to do 3. I'm going to directly substitute in. Which one will I put it in, first or the second one? Because it's greater than 1. 3 minus 2 is? 1 squared is? Negative 1 plus 1 is? Very good. This one right up here, I don't need you to think about that, because that just did more bad than good. So I'm skipping it next period. I just need you to focus on these 3, okay? You're not going to have anything like that, okay? Are you good? Okay, let's look at 19. Alright. We've got a piecewise. X is greater than or equal to 0. X is less than 0. Okay. That is my point of discontinuity right there. We're jumping in the graphs at these piecewise at that point. Okay. So I want to know the limit as X approaches 0 from the left. Would be the first or the second one is the left of the function. I'm going to do direct substitution. Always try direct substitution, just like we learned. If direct substitution doesn't work, that's when you pull those other strategies out. Factoring, rationalizing, all that. Are we good on that? So I'm going to plug 0 in. Anything raised to 0 is what? 1 plus 2 is? Oh. Yes. 1 plus 2 is 3. 0 from the right. 0 minus 5 is? Very good. Did I get the same thing? So what's my overall limit? Very good. Next, I want the limit as X approaches negative 2. Where would negative 2 fall in what piece? On the bottom. Apply direct substitution. E to the negative 2 plus 2. I want you to do that in your calculator right there. Do 3 decimal places. What did you get? 2.135. Okay. Are there any questions on piecewise? All right. Let's turn it over. We already discussed all this, but we're going to go back over this. What is the asymptote at this graph right here? 4. Why don't you graph it? Graph it. Is it a horizontal or vertical asymptote? So it's going to be x equals 4 or y equals 4? X equals 4. Remember, you set the denominator to 0 to be x equal. Alright, now, we're going to find one-sided limits algebraically. What we just did was piecewise. Now we're going to find one-sided limits algebraically. Okay, we're going to cross out something here because me and Miss Hopper, after we typed these, said we didn't like this. So what you're going to do first is let's cancel that out. Alright, you have 3 scenarios that come up in one-sided limits, okay? 3 scenarios. Always you apply direct substitution. If direct substitution gives you a number, that's your answer. You're done. If it doesn't give you a number, and you come up with 0 over 0, your answer's not 0, that means you got to do something else. If it comes out to 0 over 0, you need to do some factoring and canceling out, okay? If it comes up to a number over 0, you got to memorize these rules. If it comes up to a number over 0, you pick a number near it, that means next to it, and plug it in, okay? And the way I remember, if it's a number on top, pick a number near. Number on top, pick a number near. Does everybody see that? Okay, so let's look at this. On number 20, this is a one-sided, because I see as x approaches 3 from the left. I'm going to do direct substitution, see what I get. 3 plus 1 is 4, and 3 plus 3 equals 3 plus 3 equals. So that gives you 2/3. Is that a number? That's your answer. Number 21. I'll plug 3 in it. 3 minus 3 gives me 0. That gives me 0 over 0. So I have a 0 over 0 situation. Well, then I need to try to do some factoring here. Okay? So x minus 3 over x plus 3, x minus 3. These cancel out. I'm left with 1 over x plus 3. Now I'm going to do direct substitution. Plug 3 in. 3 plus 3. So your answer is 1/6. Now, guys, I don't want you to get this confused overall with one-sided. You only do these rules when it's one-sided. Overall, always apply direct substitution first. That's the common in both of these. You apply direct substitution. From there is when it changes. On these overall, you might have to do factoring, you might have to do find a common denominator, or rationalize. On this, you have these 2 strategies you have to do for one side. Do you see the difference? You're going to have to learn that, okay? We're going to review it every day. Yes?
So does it matter, like, whether it's coming from the left or the right? Okay.
It will in a minute, though. Number 22. I plug a negative 2 in, guys. A negative 2 plus 2. And this is where it's got to matter. Negative 2 plus 2. That gives me some number over 0, don't it? Well, then that means I got to pick a number near. That means on either side. I got, okay, if I'm negative 2 here, what number over here on the number line?
Negative 3.
And what's over here? Now, this is where it matters which number you pick. Where am I approaching it from? So would I pick negative 3 or would I pick negative 1 to plug in?
Negative 1.
Do you see where that matters now? Okay. So, I got this. So that lets me know I need to pick a number near it. I'm going to pick negative 1 because I'm dealing with the right side right here. Right side. So I'm going to go negative 3 over negative 1 plus 2. That gives me negative 3 over 1, which is negative 3. That is not your answer. That's just going to help you get your answer. When you have this scenario, guys, when you have this scenario, some number over 0, it's going to be going to a positive infinity or negative infinity. That's going to be your answer, okay? If you have a number over 0, that means it's going to some type of infinity. This is how you use your answer to predict. If you get, like here, we came to a negative value, didn't we? That means it's going to negative infinity. If I would have got a positive value here, that means it was going to positive infinity. And the reason it's going to infinity, guys, can I cancel anything out to get rid of that x plus 2? So that lets you know there's an asymptote there, isn't it? And what you know about asymptotes, they're going to go to infinity or negative infinity, don't they? So do you understand why your answer is an infinity here? So this would be negative infinity. let's look at number 23. First thing I do is I apply direct substitution. Plug 3 in. 3 minus 3 is what? I need all eyes up here. 0. So I got some number over 0. Well, I should be able to look at that problem and say, okay, I can't cancel that x minus 3 out, so that means there's going to be an asymptote somewhere. Now, on the number line, I have 3. I'm number 3. What's on this side of me? What's on this side? I'm approaching it from the what side? Left. So what number would I plug in? 2. So I plug in 2 minus 3 is negative 1. Negative 1 squared is what? So 2 over 1 is, that's not your answer, but you help use it to predict. It's going to be positive infinity. Number 24. I apply direct substitution. Negative 3 plus 1 is, on top, negative 3 plus 1 is, negative 3 plus 3 is 0. A number's on top, so I'm going to pick a number near. Number near. Okay? I want to come from the right, so what's something on the right of negative 3? I'm going to plug that in. I get negative 1 on top, and I get 1 on bottom. It gives me a negative value. That is not my answer, but that means I'm going where? Negative infinity is my answer. Let's get down to number... Oh. I want to take off these signs right here. Let's take these 3 signs off. Bless you. Alright. So right here, guys, this looks like overall. This is like overall what we did the other day. Let's just say, now I'm putting it all together, and that's what we're just going to be reviewing. Just what situation am I given? What do I need to do? I got this problem. X negative 1. First thing, I apply direct substitution. I get what in the denominator? 0. Okay, I think back to my toolkit strategies. It was factoring. Can I do any factoring there? No, I can't do any factoring there. Can I rationalize the denominator? No. Can I find a common denominator? No. Oh my God, what am I doing? Like, all that's out. So what do? It doesn't say right or left. I took that off. So on this particular problem, if none of that works, what you're going to do is choose a value to the left and to the right and see what's going on, okay? So what's to the left of negative 1? Negative 2. Let's plug that in. I get a positive 3. That means it's going where? Positive infinity. Do you agree with that? So I'm going to put positive infinity right there. Okay, I'm going to plug in 0. 0 plus 1 is? 0 plus 1 is? Negative 3 over 1 is a negative 3. That means it's going where? So I got one side going to positive infinity, one side going to negative infinity. What's my overall limit? Does not exist. That's what you would have there. Does not exist. Alright, let's look at this. Number 27. I have negative 2. I directly substitute negative 2 in there. What is negative 2 squared? 4 minus 4 is? 0. So stop with the direct substitution. Let's try one of my toolkit strategies. Can I rationalize the denominator? Can I find a common denominator? Could I factor? Factor's the only thing I could do here. So I'm going to have x plus 2 over x plus 2, x minus 2. I'm left with 1 over x minus 2. Now, I'm going to try to direct substitute one more time before I have to pick a number to the left and right. The number to the left and to the right is your last resort. You got me? So I plug negative 2 in. What's negative 2 minus 2? Am I good now? Yes. Then my answer is negative 1 what? Very good. One more. Oh, is that the same problem? Oh, positive 2, okay. I plug 2 in. I get 0 in the denominator. So I have to go back to my original toolkit structure. Can I rationalize here? Yes or no, class? No. Can I find a common denominator? So what's my only thing I can do? Factor. I'm going to factor that. Alright guys, these cancel out. I'm going to try direct substitution one more time. I directly input 2. What do I still get in the denominator? I can't do that, can I? What's my last resort? I'm going to pick a number to the what? And to the? Alright, let's pick one. What is to the left of 2? 1. That gives me a negative 1, which is negative infinity. I pick 3. What's 3 minus 2? I get 1 over 1, which is, so that means positive infinity, don't it? So I got negative infinity. One side's going to negative, one side's going to positive. So what's my overall limit? That was a good class discussion today. Have a great day. Your homework's on the board. Tomorrow I'm just going to throw limits at you and tell me what we're going to do. Throw limits. Does that make sense? Hey, bud. That's your. And I'm going to do that same. I'm sorry. No matter what time it was. Yeah. Still got I can't figure it out. Yes. I needed to look at that. I did 3 like that. Good. Let's take that. Is that okay, Josh? Tomorrow we're doing training. The problem is that how will it That's not here.
Okay.
How you doing?
Fantastic. So I'm being completely late to school. I'm not doing my homework, so.
Mary Catherine, here you go, hon. Way on C Hall. Bottom floor past your dad's room.
Actually, I got here in time. I got here at 7:15, and I left my book bag at home. So I'm
Oh,
on
God.
my way back through traffic.
Hmm?